Good morning. We're looking here now at F equals ma, Newton's second law. Force is equal to mass times acceleration. Alright, now we have young Bob here who's recently won the lottery on his new bright yellow aeroplane, and he's going to demonstrate some examples for us. It's a very light aeroplane, mass 100 kilograms, accelerating at 10 meters per second. So, using Newton's second law, the resultant force, this resultant force really would be the driving force of the engine, which is equal to his mass multiplied by his acceleration, which is 1,000. Now, force newtons. Okay, pretty simple really. Let's look at the next one. If we take air resistance into account, so there's an air resistive force of magnitude of 100 newtons opposing motion. What is the new driving force of this aeroplane? So using F equals ma. Now F is the resultant force acting in this direction. So we've got driving force minus the resistance is equal to the mass of the aeroplane multiplied by its same acceleration there. So this is going to leave us 1,000 plus 100, so the driving force is now 1,100 newtons. Makes sense? It's had to increase by 100 newtons to keep the same acceleration acting against 100 newtons resistance there. Let's look at some more complicated examples. Right, you can get forces in I and J components. Now, what we're looking at here is you've got Cedric and his jet ski. Oh, the waves are moving. Okay, Cedric's moving. And he seems to have lost his crash helmet. We'll have to find that for him. Okay, jet ski, force of 7i plus 3j, magnitude of this acceleration. Let's find this acceleration vector first. So, F equals ma. We have the force of 7i plus 3j is equal to 10 multiplied by a. So we can see acceleration vector is, oh, funny zero, 0.7i plus a 3j, hang on, let's start this one again. A equals 0.7i plus 0.3j. Obviously all I've done is divided both sides by 10. Magnitude of the acceleration, so it's a vector, should be underlined. Magnitude of that little puppy there is going to be the square of each square rooted, because what we're effectively saying is 0.7 on the I, 0.3 on the J, right angle triangle, using Mr. Pythagoras to find the hypotenuse. Okay, that gives us a magnitude of 0.76 meters per second. Right, next one. Oh, we've got Cedric and his truck again. Excellent. Now Cedric is now moving up the slope. So let's have a look here. What we need to be doing now is not just saying F equals ma, but stating the direction. Now we're going to be using F equals ma up the slope. Okay, so the resultant force up the slope, we've got 20,000 newtons, 20,000, hang on a sec. Okay, where was I? Yeah, resultant force is up the slope, 20,000 newtons, minus the resistive force of 2,000 newtons here, and then we have the components of the weight as before, component in this direction and in this direction. That angle's 20, so this is moving through the angle cos, this is moving the opposite, which is sine, so the component of the weight is 1,000 g sine 20. So that there, all that I've written, is the resultant force acting on the truck. That's equal to the truck's mass of 1,000 kilograms. It's not 1,000 g, that's its weight. 1,000 kilograms times its acceleration. Okay, so I have all that, and I can find its acceleration as a worryingly large 14.64 meters per second. Every second, Cedric's truck is increasing its velocity by 14.64 meters per second. That's tremendous acceleration, and obviously there's no real way that would be happening in real life. It's also asked us to find the coefficient of friction. As the truck's moving, friction is maximised. Where can I do this? Let's do this over here. So F equals frictional force is equal to coefficient of friction multiplied by the normal reaction. So as we've seen here, normal reaction R is balanced by this force here. So if I was to firstly resolve in this direction here, I would get that R is equal to 1000 G cos 20. So I can use that in here because I know that the value of frictional force is 2000 newtons cos it's here, and that's equal to a mu times 1000 G cos 20, cos that's the value of R I've just found. From that I can get mu to be 0.11. Right, so key points here are F equals ma, state the direction you're using it in. F is the resultant force acting on the object, okay, which will create an acceleration, and F equals ma. Force is equal to mass times acceleration. As always, thank you for listening.